Hello everyone, in this video we'll be discussing about templates in C++. So in function overloading, we saw that we can have different functions performing different tasks, but they have the same name. The only difference is that they differ in the number of arguments they take in or the types of the arguments. Now imagine you have a piece of functionality which you want to implement for different data types. So with function overloading, what you'll have to do is you'll have to write down the function again and again and again for each of the data types you'd want to work it on, which is kind of cumbersome. So how do we make it simpler such that we have one function which can work for multiple data types or whatever data types you feed it to? That's where templates come in. So templates allow us to make more generic functions or classes such that they work on a wide variety of data types. So how we define or create a templated function or a template class is in this manner. So we use the keyword template followed by these two bracket symbols, and within which we write type name and whatever you want to call your new data type as. So what this type name can also be replaced with class. So this class will be different from the definition of a class, but here they can be used interchangeably. It does not mean that we'll have to define a class called T. It just means that we have another the data type being used for this template will be T instead of something else. So after you've done that, within the function you can go ahead and use T wherever you would use your own data type. So for example, this is a function which I have written to calculate maximum of two given inputs. So our inputs could be integers, they could be floating points, they could be characters, they could be strings. So I want it to be generic and work for all such data types. So what I do is I make a template out of it in which there'll be two inputs of type T in my case instead of type int or type char or type string. So in my case, it'll be type T, A and B. And if A is greater than B, I return A, otherwise I return B. In this way, we create a templated function. Now, how we use it is in this manner. So what we do is we call the function name, and again, within those brackets or the greater than and less than symbols, we write whichever data type our T should take place. So when we write it's int, we mean that T everywhere will be replaced with int. If we write float, then T everywhere will be replaced with float. String, it will be replaced with string, and so on. So what I've done here is I'm printing out the maximum of these two and the maximum of two strings as well. So we see that the maximum of 1 and 2 is 2, and the maximum of hello and this is me is this is me. So what happens when it comes to string is that we know that when you're comparing two strings directly using the greater than or the less than symbol, it will go on comparing them character by character, and whichever place they differ, it'll then calculate the difference in their ASCII values and print out as per the maths which goes on. So that is about template functions. Now, similar to how function overloading, we can have multiple parameters as well. Here also in templates, we can have different inputs to the templates. What I mean by that is we can have different data types in which both are generic. So in for the function called fun2, we have a template in which I've given class A and class B. Remember, this class does not actually quantify that A will be a class and B will also be a class. No, it is just used in place of type name because that's how the keywords work for templates. So I can have the template working for two different types now. So what it does is it takes in an input of type A and it takes in an input of type B as its arguments. And what I'm doing then is I'm printing out a sum of those two. Now for normal cases, we can imagine that, okay, if I given an integer and a float, it will work. If it's a float and a character also, it will work, because character will implicitly get converted to an integer, and so on. But if you try to do something such as passing a to be an integer and b to be a string, then the error will rise. So for example, if I try to call fun2 with float and a string, and I pass in the respective arguments, we'll see that an error will be raised, in which it will state that there is no matching operator which works for a float type and a string type. So if you want that to work, you'll have to overload the operator again. Right. Now, one more thing about the template functions themselves. So we see that for strings, what is happening is it's comparing character by character, and wherever they differ, then depending upon their ASCII values, it's giving me an output. But what if I don't want that? What if my function is generic enough for almost all the data types, but for some certain data types, I want them to behave in a specific different way? So what I can do, what templates allow us to do, is to make a specialized function working for that specific data type itself. That is called template specialization. And how you do it is like this. What you'll do is define something, or precede the function definition with this, and then go ahead and define your same templated function, but using whichever particular data type you want to use. So in my case, it's string, so it'll return a string. So in place of t, I'm writing string. It'll be maximum, and it will be called for a string data type. I'll take in inputs of string as well. So now within this, I have my own definition, which says that instead of comparing them value by value, I just want the longest string. So if a's length is greater than b, I'll return a, otherwise I'll return b. So let's give it a longer statement. Hello, this is devtown. Let's compile a function, compile a program, and let's run it. So we see that the functionality indeed has changed, and we get the longest string as our output, instead of them being compared character by character. So we learned about template functions. We learned about template functions being able to take different data types as well. And we also learned about template specialization. Now let's go ahead and learn about template classes. So similar to a function, when we want a class to have a generic data member, what we do is we define it to be of a template. So template type name t, class A. Why did I do that? Because I want its data member small a to be of a generic type. So then what I did and is that I went ahead, I created a constructor, I created a parameterized constructor using the same template t. Then I have a function called show. I have a function called test t, which again takes in an input of type t. It then prints out the value of it, adds the data member and whatever parameter you're passing, and prints it out to the console. And then this example shows that even inside a templated class, we can have another template function. Now what happens is, for this entire class, t will although t in itself is generic, within the class t everywhere will have the same name. Now what if I want a function what if I want a function within a class which is generic? So I cannot actually go ahead and use t over here as well, because firstly it will show an error that it is not able to recognize the difference, and that t has already been defined. So what you do instead is you can use any other character or any other name, whichever you want to give to your type, and use that instead, so that in this way you can have a templated function within a template class as well. Now let's see how we can define we can define a member function of a template class outside the outside the definition of the class. So this is how you would do it. So while defining the function, you'll have to specify that it belongs to class A, yes, but it will be of type T. The class A of the particular template T, that is what the show function will belong to. And since we are using T, we'll also have to define that it actually belongs to a template which takes in a type name T. So here all I'm doing is I'm printing this value onto my console. So then I call a.show, and let's see the outputs. Right? So I had initialized a to be of wherein a will follow the template, but the template will now be that of an integer. So it will be of a class. So it will be of type int. And then I'm initializing the okay, let's actually use some other name instead of a, because too many a's will be confusing to hear. Right. So I have an object obj which is being initialized by 10. So what this actually does is the small a within our class, the data member, will get initialized with 10. Then obj.show, which we have defined here, is simply printing it out to the console. So we get the value 10. Then obj.test, what does it do? Test again takes in a parameter of the same type of the class, which is t. And since t is int in our case, I'm passing an integer as an argument, and it prints out the sum of that particular formal parameter passed to the actual parameter passed to the function, and the internal the data member a. So 10 plus 20 is 30, which is observed. And then what I'm doing is, of our template class, which is of type int now, I'm calling, it has a template function called fun, and now I'm calling that fun to be of int. So obj.fun of type int, it takes in an argument of the same type again, so type 10, and what it does is it adds 10 to that value and it prints it out. Now let's try to work it with a character. I make it a character and I pass h. So we see that h plus 10 gives us r apparently. And then what I can do is I can make it a float. I pass it 1.1, and it gives us 11.1. So we are clearly able to see that this template in itself also works inside our templated class as well. So this has been about generic functions using templates in C++ and also template classes. Thank you.